Welcome everyone, and thank you for attending our webinar today. My name is Ron Pullis, and I'm with the Intel Data Center Management Solutions team. Today we have teamed up with NetZoom to discuss and demonstrate NetZoom's solution to save power in the data center. During the webinar, please remember to ask questions using the Q&A link below the presentation screen, and we'll answer them as they come in. We've also attached the PowerPoint file of this presentation along with a white paper from NetZoom, so feel free to download those and share them with your colleagues. So now I want to welcome our presenters. Our first presenter will be George Clement from Intel. George is one of our senior application engineers here at Intel. And our second presenter will be Kirti Yadav, the Director of Product Development for NetZoom. And Kirti will be followed by Richard Combs, a Senior Product Manager for NetZoom, who will be showing a demo of NetZoom's solution. So we'll get started with George. Welcome, George.
Hey, Ron. Thanks a lot. Okay, so hi, everybody. Welcome to the webinar. I'm going to go over some just broad topics related. And then, obviously, I'm going to, keep these elements in mind as I kind of describe them, so that you understand basically how they're being leveraged through, through capabilities that we expose in NetZoom technologies. And so you'll be able to see through this whole webinar, hopefully, a good picture of how Intel and NetZoom are working together to kind of expose hardware elements, telemetry data, further analysis to basically drive your ROI and capabilities even further. So with that said, I want to start with basically some of the data center broad picture things here. Basically, whether you're customers or whether you utilize on-premise, public, or hybrid technologies, you are obviously driving a lot of your decisions around the telemetry data that you get from those solutions. In the data center space, obviously the hardware capabilities drive a lot of your ROI and value, as well as decisions on expansion, how things are going with your customer base, the performance of your applications, and so forth. In public, those telemetry elements are basically exposed through APIs and drive a lot of your application development and choices and functionality as the application serves the customer population. And hopefully it's as efficient as possible, and it's driven through data and decision-making capabilities. The final one is hybrid capabilities. Basically, that's the hybrid solutions, and that's really around the mix of basically where you have the data center as well as the cloud and working together to expand your capabilities as further. Now I'm getting some audio chopper reported, so I'm going to try and make this more efficient for you so that you can hear me effectively. But if it continues to be a problem, I'm sure the moderator will let me know, Ron. So
okay. Yeah, I'm getting the top too. So, yep.
Oh, are you? Okay, I'm just curious. Okay, so basically the 6 pillars of capabilities of success that we have within the data center space is really to basically servers. Being able to support those systems cross-platform. That means basically regardless of what hardware you've deployed, the ability to basically support whatever it is inside the data center space. As well as broad coverage, for all the IT devices in your data center. So that means that basically we have, this broad capability we've provided across a lot of different IT devices, and we're actually including historical information. We're recording all of this data real time and providing trends and predictions from this data that helps key customers and their applications make better decisions about progression of, of expansion, dynamic expansion, contraction, to basically make an efficient environment, whether it be on-prem, in the cloud, or in a hybrid capability. So that said, basically, we have these capabilities, and we're providing them dynamically, and we're collecting this information directly from the hardware. How we're doing that is collecting it through the out-of-band capabilities that are provided through the servers. And that information basically is collected, to help improve asset management, data center reliability, maintenance, and optimize the power and cooling efficiency inside the data center, and maximize the compute. We have a ton of ecosystem partners here, and specifically today we're going to talk to NetZoom, who's fantastic about helping us and working with us to serve the customer and population. So I want to really get to them and discuss basically what their overall capabilities are and how it's best serving the market. So to do that, I want to invite Kirti on the stage and basically have her kind of go through the overall solution that she's providing and directing, and how it's serving their customers. Kirti?
Thank you so much, George. That was a great introduction to the powerful capabilities of Intel DCM's technology. Thank you everyone for joining us today for today's webinar. My name is Kriti Yadav, and I am the Director of Product here at NetZoom. And I'm super excited today to be having this opportunity to present to you some familiar challenges and the very exciting solutions that we have available to resolve these challenges. So throughout the webinar today, if you have any questions, please feel free to share them via the chat box. So please feel free to share them via the chat box, and we will certainly address them towards the end of the webinar. So today I'd like to focus on some key topics that really matter to people who work day in and day out at their data centers. I want to address some of their key issues, and more importantly, share with you that there are easy ways to solve them. There are solutions to these problems, and there's absolutely no reason why one must face these challenges on a daily basis. Intel and NetZoom have partnered together for the last 5 to 6 years, and today I would like to talk about the most comprehensive solution that we bring together to solve your common but critical issues, and how this solution combined will deliver instant return on your investments. Okay, so we all know that nobody buys a DCIM with the intent of simply running it, spending months and months collecting data, collecting their assets and inventory just to create some nice pictures and documentation at the end of it. It is certainly part of it, but that's really not the whole sole goal. One of the primary goals is to get instant ROI on this technology that your organization has decided to invest in. How can we make this thing work for us? How can we make sure that it will literally pay for itself within a reasonable span of time? So we know that data centers today face some common but crucial challenges that just cannot be ignored. These problems aren't new, but until recently there just hasn't been a full comprehensive solution to address all or even most of them. Data center professionals have just been doing the best that they can with homebrewed or partial solutions or your infamous spreadsheets, and honestly that's just getting a bit tiring. Our data center operators are tired of manually tracking their power consumption at every level of multiple data centers and never still really knowing why their power consumption is so high. They're tired of manually tracking where things are overheating. They're tired of not being able to plan proactively. They're definitely tired of finding out that things have blown up after the fact because they just had no way to plan proactively or monitor these pieces of equipment. So wouldn't it be nice to have one single solution that could address these problems? So today, I'm going to focus on the real challenges that keep data center professionals awake at night. I will talk about how to monitor power and temperature in real time. I will talk about how to better monitor the physical health of your devices. How do we find out about potential failures and risks in real time and more proactively? How do we identify the right candidates for tech refreshes at the right time? How do we find these underutilized or ghost servers that eat up all of our power unnecessarily? How do we create better resolution plans for potential issues and troubleshooting and identify possible impacts down the chain? And how do we better provision our racks for capacity planning? So let's talk about power consumption for a minute. We know that this is one of the biggest costs of operating our data centers today, and it's only going up with the cost of power. Running your data center is already costly, and many of the data centers operate as if their equipment are running at the nameplate value. Now, if you're not familiar with the term nameplate value, it is simply the max power draw that the manufacturer has documented. No doubt none of these devices truly run at this max power draw, and this in itself becomes a huge reason for inefficiently operating the data center. Running a whole data center at nameplate value, which we all know is way too high, and then adding to this issues like downtime due to a lack of actionable data and manual planning methods, you're looking at a major money sink right there. The good news is that there are tools available to solve all of these problems, and DCIMs on average help reduce power costs by almost 25%, if not more. And using this, IT and facility managers can now make better and more informed decisions about overall capacity usage and determine to delay or prevent those costly new build-outs. I mean, just take a look at the numbers, and they're going to tell you the story. Today, energy costs are one of the fastest rising costs in the data center per Gartner, and an average cost per outage that you see is about $29,000. And these are the hard numbers. This doesn't include the cost incurred with the impact to your day-to-day business. Think about the soft costs that make an impact to your bottom line. Now, we all know that it takes about a full working day to recover from an outage, and that doesn't make for a happy picture either. And yet, almost half of the data centers still rely on manual methods for capacity planning and forecasting. In fact, nearly 1/5 of them are relying specifically on sensors and spreadsheets to maximize cooling efficiently. This in itself creates a huge issue with knowledge transfer for your infrastructure, because when the folks maintaining your spreadsheets move on, so does the information with them, and then it takes a significant effort for that next guy to make sense of the data that was left, leading many times for them to have to redo all that effort from scratch. And with that, almost a third of our data center operators end up feeling that they do not have sufficient data to take the right actions or plan better. Now let's get more specific into some of the big culprits for these huge power draws. One of the specific causes of excessive power draw are low or underutilized servers, better known as ghost servers. A lot of these servers get added to racks and then forgotten about. Nobody's tracking them closely, usually because there are not sufficient tools in place to even keep track of them. And these servers then in turn sit there drawing power, not actually doing anything productive. Even worse, up to 30% of such servers in live data centers are ghost servers. Now, every data center is different, and each data center situations are unique. But think about your own data centers. Do you have dedicated teams to track these underutilized equipment? And if you don't, what would be the impact to the bottom line of your organization? And if you do, how would you better utilize those resources that you just freed up from tracking these devices manually? Okay, so let's say we want to start attacking this problem now. How do we deal with this issue? How do we eliminate this excessive power sink and cost? How much of an ROI can we expect? How do we get our decision makers to decide that this is a worthwhile issue? Well, on average for a data center of roughly 300 racks, you could see savings of up to $100,000. Now that's just for 300 racks. Imagine if you're dealing with a bigger data center. The savings just shoot up. Simply having real-time monitoring of such devices for their power utilization can help you identify ghost servers quickly and easily. And then you can make the decision to convert these to VMs or decommission them or repurpose them as you find appropriate. So let's look at these numbers a little bit closer. Close to 60% of servers are between 10 to 50% time utilization. About 40% of them are between 1 to 10% of time utilization, and about 1% of them are less than 1% time utilization. Just powering up these servers can yield $1,000 per year. So what can we do about this menace to our bottom line? How can we start locating these ghost servers? Fortunately, it's possible to measure these key metrics like CPU utilization in real time to instantly identify these power drainers, and then you have the option to choose to either decommission them or repurpose them as required. Once you have found these servers and you are monitoring them, it is easy to do some quick math and prove out what the savings of shutting down would look like specifically for your data center. Using a DCIM that has the ability to track and monitor your servers this closely can be the answer you're looking for. But we know this isn't our only issue, right? So let's talk more about rack density and how power provisioning relates to it. There's a lot of MDRUs out there.
Can we pause? Can we pause for a second? We have some questions.
Yes, of course.
Do you want to address them now?
Absolutely.
Okay, so
I see some questions here from the audience.
okay.
So give me one second, George. Let me just kind of go through the questions. It says all IT devices. Does that include non-Intel processors like networking equipment? I think this was one of the questions that came in as you were presenting, George. Do you want to talk a little bit about this one?
Yes. Yes and yes. We support outside of we support other processors and other IT devices, including PDUs, UPSs, and various other IT devices, and they filter through and are supported in NetZoom as well.
Thank you. And I see the next question here, what telemetry is required and necessary for the NetZoom tool? I'm going to hand this over to my colleague here, Richard Combs. He's going to help address this question here.
All right, Kriti, thanks very much, guys. So I see the question here is what telemetry is required for this. It is a discovery that uses the integration between NetZoom and Intel DCM. The discovery is targeted and agentless. So long story short, the way it works is that their Intel DCM is installed on its own VM or server, and the NetZoom application server communicates with Intel, and Intel directly interrogates the devices. And the way it's set up is with a discovery across a Class C subnet up to 255 IPs, and you can select what protocols are used to interrogate the devices. And I'll carry that straight into the telemetry kit required. The only real kit you need is Intel DCM, and again, it's targeted agentless discovery, and you can select what network protocols are used, at least as far as the NetZoom and Intel integration is concerned. George, maybe you can speak to a little more detail on how that works.
Well, I mean, thank you for that description, and basically that should be a testimonial to how closely we work together, but because it's great. But yeah, I mean, basically, we're out-of-band communication. We collect data via communicating directly with the baseport management controller on the servers or the other IT devices. If the IT device does not have a BMC, we collect it via the most unobtrusive way. Most of that time is basically through some service processor or network capability, including SNMP. And then, we provide we expose APIs that basically NetZoom leverages to basically make this a very tight integration for customers. It's seamless. It appears as if it's NetZoom just doing all the work, and where it's a cooperation between Intel and NetZoom at this point. I don't know if I missed anything there, but.
I don't think you did. I think that, like you said, it speaks to the excellent collaboration we've had with this solution, for these last couple of years. So there's one more question we've got here. How are you determining utilization of a computer CPU cycles across OSs, Linux, Windows, and how do you address systems that are known idle due to being on standby for high availability? Can you speak to that at all, George, as far as how Intel handles that?
For high availability, and I apologize if I'm still choppy, I may need to rejoin with it, but basically for high availability, we're really looking for customers, for our capabilities are mostly monitoring, but there are some management functionality there. We basically leverage virtual machines for most things when we're looking about high availability, primarily because they provide the nice combination of basically robust infrastructure, supporting it, as well as basically the ability to move that VM around from place to place. And then we'll support, high availability solutions in customer deployments because we're agentless and we're not really looking at the operating system. We're collecting even further and deeper at the hardware level, directly talking to the firmware on the systems, and then the network environments and other things we're using unobtrusive protocols that are already exposed.
Right, and as far as the CPU utilization, that's basically discovery will receive that information from interrogating the device just like any other capacity data, right?
Exactly. If it's exposed through out-of-band communication, we do it that way. Mm-hmm.
Right. Okay, so I'm going to also make sure we cover this other one. How often is the telemetry required to be recalibrated, and does it require assets to be powered down? You can do one discovery from the NetZoom Intel DCM integration, and that's going to keep the device discovered as long as the device stays powered on and the Intel server is on and communicating with NetZoom. You don't need to do anything else with it. You always can manually rediscover it whenever you want to refresh things, but the devices never need to be powered down. Let me carry up into the question we just got a moment ago. I did say 255 IP addresses from one class C. What I mean by that is there's multiple discovery networks that you can set up in the Intel DCM integration in NetZoom. You can have an unlimited amount of networks set up across any site. That gets a little deeper into how NetZoom handles it, but you can discover unlimited devices. It's just that per a discovery, we're limited to a Class C due to bandwidth restrictions and the way Intel discovery works as well. George, maybe you can speak a little bit more to our limitations in that area.
Well, I think, yeah, I mean, from our perspective, the Class C elements could be broader, but, you know, for most discoveries, we're exposing this through API, so we expect, you know, if NetZoom needs to broaden that, they can programmatically do that and abstract that away. So it's more of a matter of basically how many IT devices do you want to handle in one automatic discovery.
Right, that's true. And from what I understand, we do also need to have unique IP addresses per each Intel server, correct? Like if you have a Class C of 192.168.1 subnet on two different sites, then you wouldn't put that on the same Intel server, correct? George, we've lost you on audio.
I apologize, I was on mute. Yeah, multiple networks with the same IP structure can be problematic. Well, can be a challenge and require other networking techniques like NAT or something like that or whatever.
Right.
So yeah, DCM is best at individual sites, at an individual site, predominantly because of just networking challenges and other things. But in most cases, we can even go regionally as far as monitoring goes. And then we're happy to work with NetZoom to basically cover the entire networking spectrum for customers and pull in all the IT devices, including the servers. And obviously, they don't have to be Intel processor necessarily. You know, and for all of the communication is out of band directly with the hardware. So we support various different formats and configurations as well as IT device choices.
Right. All right, so we've got a user here that's saying his VLANs are /22 networks over 1,000 IPs. I'm not going to say that you couldn't do that, but at least as far as the NetZoom integration, we would recommend doing it in 250 to 255 chunks, just because of the way the networks are configured and the discovery runs. Just if nothing else, due to the amount of time it would take to discover 1,000 IPs in one shot.
Right.
And George, you can
that's
speak
fair.
a
I
little
think
bit about Intel does
I think that would be. I'll just make sure I don't mute myself again. Yeah, basically, I would agree with you there. It's basically a matter of, you know, how many devices do you want to bring in at one time, and I think that's fair. That's a pretty good number, you know, to basically leverage. But we will certainly, once they're in, DCM will be happy, and obviously NetZoom will be happy to monitor and can scale much past those numbers that customer was talking about.
All right, so guys, we're going to take this last question here, and then we're going to proceed with the rest of the demonstrations, and we'll collect all the rest of the questions and do a QA at the end. So with a Class C, no, we're not restricted to just a 192 structure. The way NetZoom works is just a Class C or 255 IP address structure per a network. As far as the actual numbering structure, what you're actually using, what numerical subnet you're using, NetZoom doesn't care, and correct me if I'm wrong, George, but I don't think Intel cares either.
Nope. We're just happy, but no, we're not. We don't necessarily, there's no restriction there.
Yeah. Okay. All right, guys. Thanks very much for your questions. Please keep submitting them as we go on. We're going to finish up with the slides here and then get into a brief demonstration of how NetZoom handles capacity management, and then we'll get back to the rest of the questions. I'm going to give this back to Curtis so we can keep going.
All right, thank you, Richard. I appreciate that, and thanks for answering those questions there. Again, please keep the questions coming. This is really helpful. This is exactly why we're having this demo to begin with, and the presentation to begin with. So we'll definitely be answering more of these questions towards the end of the webinar. So we'll go ahead and continue here with the presentation and talk more about rack density and rack provisioning as we were discussing before we took up the questions. So we do know that with data centers at this point in time, we recognize there are a lot of empty RUs out there in a lot of racks, and we know that it doesn't have to really be that way. But the reason why it is like that today is that there are so many people who feel like they're forced to configure their racks like this, leaving so much stranded capacity in terms of both space and power. Now, why is that? That's because most of these racks are provisioned based off of device nameplate values, which again are those maximum power draws set by the manufacturer. So we know that PDUs, UPSs, and power breakers are only allowed to have so much power draw, and therefore since a power source can only support so much, we end up with fewer devices on the rack, assuming that they will put us close to the threshold. This in turn leads to racks only being allowed to have so many devices in them, especially if those devices have high nameplate power values. And now the National Electrical Code also requires that power breakers be set to no more than 80% of the max load. But keep in mind, in most cases, your racks and data center can operate at full processing capacity with values well below the nameplate suggested. As I mentioned before, each data center situations are unique, so think about your own data centers and how this impacts the challenges you are facing in your data center. Now, simply using real-time monitoring technology and coupling that with a DCIM can help you reduce power provisioning to the minimum required for your data center. This will lead to massively reducing your power waste. Statistics share that for a data center of close to 300 racks, the rack density can go up by almost 70%, and the overall savings that you will realize are going to be more than $1 million. So what is the solution? In a word, it's provisioning. By provisioning smartly or reducing the amount of power you assume each device to draw, a number of beneficial things can really happen. First of all, your overall power draw can drop immediately. Who doesn't really love that? But that's just the beginning, however, because each individual device is drawing less power, and you can also pack your racks more densely, which imagine how many less racks you would actually need if you were using 60 to 70% more of your RUs. So with accurate capacity planning and provisioning, you can easily drop your data center costs, essentially hitting two birds with one stone, dropping both your power and space usage by a significant percentage. But that's only part of our problems today, because we have things that are heating up in our data centers, quite literally. Heating and cooling capacity management is a major pain point for many data centers. So what can we do about it? Well, by directly monitoring the heat being generated by each device, we can avoid the additional costs of external thermal sensors, as well as the stranded cooling capacity of keeping the whole data center colder than it really needs to be. We already need to wear winter coats out in the racks half the time, and I think we can all agree that letting things warm up a little bit would be rather nice. Now, if that sounds a little too cozy to be an incentive, then remember that we're looking at savings on average of about $200,000 or more annually on the reduced cooling capacity alone for a 300 rack data center. And this is to say nothing of the savings of decommissioning the thermal sensors themselves. Now, if your data center is bigger, then these savings will shoot up, obviously. Actively monitoring these thermals at the device level enables the data center to increase their overall facility temperature without increasing the risks, all the while keeping your cooling costs down. Okay, so we've stopped freezing ourselves in the data centers, but what happens when a device suddenly overheats? Well, the good news is that it's very rare for anything to suddenly overheat. If you're monitoring heat on your devices in real time, You do have the ability to set up accurate alerting based on that monitoring. Many of the data centers cannot pinpoint the devices that do get overheated, essentially failing to identify these big risks until it's way too late. What's even better is that you can decide what your heat thresholds are going to be. With this, you and the rest of your team can be responding to an alert proactively and not dealing with the disaster reactively. Proactively monitoring these temperature trends allows us to identify the devices that are at risk and alert the right users so that they can now enable proactive maintenance to reduce these failures. They can have resolution plans in place and therefore shorten that resolution time. Simply by monitoring in real time, you can save up more than $200,000 per year, and that's again just for a data center with about 300 racks. We expect power consumption savings to be between 25 to 32%, and simply the elimination of thermal sensors can result in close to $300,000 per year. And that's assuming about $100 per rack with about 3 sensors in each rack. Now, most of us have gotten that 2 a.m. outage phone call at some point, and needless to say, nobody looks forward to those. But our problems haven't really just ended yet. Another key challenge data centers face is planning those device tech refreshes. What if we could really have an incentive to do them and have them visibly have a positive impact on the bottom line? Fortunately, with DCM solutions, you can. Once you're monitoring your power draw in real time at the device level, you can do more with it than just provision for it. You can actively compare the power efficiency of devices to newer models, and then accurately plan your device tech refreshes to bring those devices in and reduce your op costs. With power monitoring dashboards, you can quickly identify servers using higher capacity than newer, more efficient models, and then choose those right candidates for replacement. Now, couple this with the aspect of contract management. I'm sure there's very few people who look forward to managing those 1,000-row spreadsheets, but if you're not one of them, fortunately a DCIM solution will let you digitally track and receive automatic alerts on various contract types, most notably the warranty. With DCIM, the right users can get alerted at the right time when a warranty is expiring or when a device is optimally ready to be refreshed. Now, give me a choice between trying to keep a spreadsheet manually updated and tracking it versus just getting an email alert automatically 90 or 60 or 30 days prior. I think I'm probably going to go with that latter option. Now, it's great to be being ahead of disasters. After all, we use our technology to be smarter and predictive, don't we? So one of the most uneasy questions you can ask being in a data center is, what happens if I unplug this thing? And that's not the worst part. The worst part is not knowing the answer to that question. What I'm talking about here is impact and business analysis tools in your DCIM that can give you a full visual mapping of all dependencies across your organization. There's no more doubt about what's connected to what provides power to what, or what assets support which of your critical business and application services. With all of this right in front of you, you'll also never have to make that your server is going down for an unspecified length of time statement, because you'll be fully capable of planning and minimizing maintenance windows and downtime, and planning better to restore those services as well. With this, you can now bridge that gap between IT and business by providing critical information when scheduling your maintenance and preventing those costly outages of critical IT services as well. With real-time monitoring and the power of DCIM, you can enable proactive alerts to your stakeholders as well when their services are impacted and as well as when they're restored. All right, so I've talked about several specific areas of capacity and monitoring, but what about overall device health? Well, the DCIM has you covered there as well. Everything from fan failures to failing power supplies, most things can be monitored these days. Your devices have the capability to talk to you, but the question is, can you listen to them? And your assets have always been offering you this information. Now you have the ability to actually listen to them directly, identify those patterns that require attention, and then armed with all of this knowledge, you can now significantly reduce downtime, outages, and data loss. Using a DCIM with device health monitoring, you can proactively schedule maintenance when hardware is starting to fail and therefore minimize risk for data loss and shorten potential outages. Even your racks themselves can be included in this. Set capacity limits for overall rack utilization of power, heat, and space that align with your newfound provision goals, and watch your op costs plummet. Now, with all of that said, I'm going to turn it over back to my colleague Richard Combs so that he can now actually show you how NetZoom DCIM can solve some of these problems and show you how NetZoom DCIM works in action.
All right, Curdy, thanks very much for that, and thank you to George and to Intel overall and to everybody who showed up for the opportunity to show you guys how the capacity management works in NetZoom.
So hey, Rich, this is George. We have some questions still, I think, sitting out there. Do you want to handle those at the end, or do you want to handle
yeah, I'd like to take those at the end.
Okay, fair enough.
Yeah, we can do that. All right, so we're going to jump right here into the NetZoom application. So guys, we talked about provisioning and rack capacity and increasing that density. If you look here, we've got an example of a server. Now, this is just a default D rating, maybe 80% of the nameplate value, roughly 1100. But if you look down here at the real-time monitoring of this server, the maximum value that we get on this is 413 watts. Guys, that is less than half of the provisioned value. You're literally looking at dropping this by about 50%, a little bit less than 50%, even if you come down to 600 just to be safe. And that's just one server. Multiply that by how many servers you have in your data center, the average 300 rack data center, and you're looking at a massive reduction in cost and power usage. Now, the other thing that I'm going to want to talk about here is those underutilized servers, those ghost servers. These are vampire power situations, guys. These are eating your bottom line alive. So if we look here, any device that is discovered and being monitored in NetZoom, you can get a list of them listed by power utilization, by CPU utilization. You can see here we've got a server that at its peak is less than 1% CPU utilization, but for some reason that server is running at 88% of power capacity, 973 watts. That server can be taken down, it can be recommissioned, decommissioned. Either way, you put this across your data centers. As Curdy mentioned previously, 10 to up to 30% of servers in active data centers today are ghost machines like this that are just eating away at your bottom line, at your power costs. And additionally, you can look down here at the monitoring. You can see that real-time power in down to 10-second intervals. You also have the option to see the same data on power. If we look on this device, we see a power spike for some reason. This device hasn't melted down. It hasn't actually gone down yet, but we definitely know we want to go take a look. Hey, why did this power spike why did this temperature spike so much within this time frame, within this 10-second time frame? All right, so now we want to come over here and look at the vitals for the device. Like we said, overall device health. Everything on this device looks mostly okay, but we do have a battery alert going on over here, a warning, so we would want to start looking at the alerts for that. And we would see here abnormal battery status on that device. But speaking of alerts, guys, we're going to want to go over here and look at the overall alerts for this whole zone. As we said, we get real-time monitoring alerts on everything going on in the data center. You can set thresholds for each of your capacities to see what's going to be happening, so you can be proactively responding to risks, not reacting to disasters. So you see we have a temperature alert here. If we click on that, it's going to bring up the details for the alert, and then if we click on it again, it's going to open us up a new tab here that's going to drill us straight down to that rack so we can immediately start troubleshooting and finding out what's going on with that rack. So the other thing that we're going to want to talk about here is the impact analysis and business services. Like Critty was talking about, we want to see what's going on across our entire business, what's going on with our business services. This is that map that answers that infamous question, what happens if I unplug this? And now you never have to not know. You can see all your dependencies across your entire enterprise. A business service, for example, here our order processing is supported by the application services of accounting software and web purchasing portal. Now you can see here we have 3 servers supporting each of these services, but you are not limited to just adding server assets. You can add VM DCMs, you can add power devices, you can add switches, you can map out all of your dependencies, you can plan maintenance, you can plan redundancy, you can plan downtime so that you have more control and visibility over everything in your assets. So the next thing that we're going to want to go over, guys, is the device replacement. So what's one reason beyond just capacity that we're going to want to look at replacing devices? It's contracts coming up on expiration, of course. So one of the great things here is we can look at these 3 servers here ready to be replaced. But why do I want to replace them? Well, capacity, obviously. We're looking at replacing servers that are less efficient and older with newer, more efficient models. But we also want to look here at the information for these servers. And we want to look at our contract data, which we can manage here in NetZoom, our warranty, purchase, and service contracts for any of these devices. We can also get reminded within 90 days of expiration, like we were talking about before, guys, let's get you off the spreadsheets. Nobody wants to manage a 1,000-line spreadsheet for warranty contracts and always be missing something somewhere. These alerts will pop up in the application, they'll email you, they'll even SMS you within up to 90 days of contract expiration. There's also the option to import contracts into the application. But that being said, guys, I'm just going to go through this device replacement and we're going to show you how easy this is. We've got a device replacement set up here with 3 servers to replace these old, less efficient servers. We see here the information of the devices that we're going to be replacing them with. We even have the option to retain connectivity and rack position so that when we replace these devices, there is no interruption. So we're just going to hit replace here and let that do its thing. We'll see here it'll run through this process quickly. So I'm going to field some of these questions while this is running here. A quick one, 80% of your server is virtualized, then you want to make sure you're maximizing the capacity management on your hypervisor devices. And you can still look at power draw for everything and cooling as well. That's where you're going to want to look at to get the value out of that. Okay, so our device replacement is done. So if I look down here into this server, you're going to see that these servers have been replaced. Those old servers are not there anymore, and we are done. Okay, so we've drilled down into individual devices, but what do we do when we need to get a quick snapshot and a quick visual? Maybe we need to present to management, or maybe we just don't know where to drill down and look. We want to start looking at capacity for overall racks or even rows of racks. So here we can see the power values for usage on the racks. You can see up here an average value. So this is color-coded to give you a quick look at what's in the danger zone. These 5 racks here are behaving, this one is not. And if you see even at a glance, you're going to see we're up in the red. There's way too much power to utilization on this rack, so we're going to want to start drilling down into that to take a look at why that is. The other side of that is temperature. Same thing, we want to look at that 3D view of the row of racks. We can see that 5 of these racks are in the danger zone as far as temperature, so maybe cooling is going down, maybe there's just too many devices in the racks. We don't know yet, but we know this is a place we're going to need to look. In conjunction with alerting and monitoring in this view, you should never even run into this situation to begin with. Now guys, the last piece of this is the power chain. Complete visualization of power connectivity for every device. We all know how it goes. Everybody thinks they have redundancy until a PDU goes down. You never need to have that happen here. You visualize the entire A and B side of your power chain all the way back through PDUs, UPSs, zone UPSs, ceiling power rails, back through the generators, all the way back to shapes that even represent the power providers. And we can move these shapes around, present them in whatever way we need to, save the visual and take it out as a screenshot so that we can show everybody, hey, this is where our single points of failure are, this is where our true redundancy is and is not. And that comes to the end of our formal presentation here, so I'm going to start fielding questions. So we answered the one about 80% of the data center being virtualized. Like I said, you're going to want to look at maximizing the capacity management on those hypervisor devices, on the power draw there, on the cooling, and all of that. So what is the process if Bob quits and you need to change the alerts for 1,000 servers? Well, thankfully in NetZoom you can subscribe to alerts. Alerts can be enterprise level. There are escalation policies. So you don't need to worry about any one person being accountable for alerts, and they can be forwarded to other users. Escalation policies can automatically notify other users. So if Bob quits, there's no interruption in service or alert management. The power profile is for specified applications running on the servers. There is application discovery in NetZoom through the discovery process, but as far as a power profile for specific applications, the discovery is not that granular yet. But that is something that we are always excited to look into. We're always looking for new ways to expand the discovery, make it more granular, and provide more detailed solutions and information. So that's a great question. Thank you for that. So I see here we've got somebody that's still, you said you're still stuck on the 255 scan devices on a Class C. You've got 20 devices per cabinet, and that means each device only has one IP address. You can only monitor about a dozen racks before you have to create a new Class C, and you're talking about monitoring 300 racks. What I'm seeing there with that is with the NetZoom integration with Intel DCM, what you're looking at here is that you have multiple networks. And all I'm saying here is that it's a Class C for each discovery. You can set up as many of these as you want, and it's very easy to set up all these different Class C subnets, to set up a discovery profile, configure the protocols, and run the discovery. So that's all I mean by that.
Yeah, once the discovery is done, basically the assets look as they did before. I mean, they're just contiguous in that entire network as you designed it. So it should be perfect.
Yeah. All right. Guys, thank you so much for coming to this. If you're interested in a more detailed or tailored demo for more specific to your data center's needs and challenges and how NetZoom can address those, please click the demo link that's available in the presentation, which will be available to you, or you can contact any of us directly, and we'd be happy to set up a more in-depth, tailored demonstration for your needs. Our contact information is available on the presentation as well. And we also have a white paper on this power capacity management available for you to download free of charge. That's available to all of you here. Please feel free to pull that down, read through that, and ask us any questions that you have about that or anything else related to your data centers. All right, guys, thanks very much for coming. This comes to the end of the formal demonstration.
All right. Thank you, Richard, and Chrissy and George as well. Good job, guys. So I just want to ask the audience to continue sending questions because we have 10 minutes left. So we'll stay on for a few minutes. If we don't get any questions, we'll sign off. But for those of you that need to go, thank you very much for attending. We appreciate it. And you'll be getting a link to this, the recording of this webinar to share with your colleagues. So please feel free to share. And yeah, and remember, as Richard said, download the slides and the link to the white paper and so forth. But yeah, thank you. We'll stay on for a few more minutes if there are any more questions. And yeah, thank you all for attending.
Yeah, thank you guys. NetZoom. Anybody else has any questions?
Okay, we're not getting any more questions, so I think we'll just sign off for now. Again, thank you all for attending, and contact NetZoom with any questions you have.
Yeah, guys,
Have a great
Intel,
day.
thanks very much for the opportunity. Thank you, everybody, for showing up.
Thank you very much.
Absolutely.
Thank
Thanks,
you.
Richard. Okay.
Right.
Bye-bye.
Bye, guys.